Hey everyone, Professor Davis here from ChemSurvival.com and the YouTube channel ChemSurvival, and today I'm going to talk to you about Dalton's atomic theory. Dalton's atomic theory was devised by an English chemist by the name of John Dalton. He was working at the very beginning of the 19th century, and he's actually most famous for his law of partial pressures of gases, but he's also, or at least should be, equally famous for being the first scientist to truly use data to support the existence of atoms. Let me show you how he did that. Let's consider two very simple reactions, the likes of which you'll probably encounter in an introductory chemistry course. We can take oxygen and react that with two equivalents of hydrogen to create water. But water is not the only thing we can make from oxygen and hydrogen. If we combine them instead in different proportions, we can create hydrogen peroxide, the likes of which you might find in your medicine cabinet at home. Now, Dalton used reactions like this to demonstrate that there must be a fundamental, indivisible particle which is combining to make these materials. Let's take a look at how he did it. Looking at the top reaction, let's say that I start with 32 grams of oxygen. I'll need 4 grams of hydrogen to completely convert that oxygen into water. And when I measure the amount of water formed, I get exactly 36 grams. Now, you probably noticed that the sum of the masses of all the starting materials in this case is equal to the mass of the products. And this observation will actually hold for any reaction at all, any chemical reaction. Let's take a look at the bottom one. 32 grams of oxygen can react with 2 grams of hydrogen, in this case to form 34 grams of hydrogen peroxide. Again, my masses should balance. We call this the law of conservation of mass, because in any chemical process it will always hold true that the total mass of all starting materials is equal to the total mass of all products. Now let's look at one more mathematical relationship. Let's look at the ratio of the starting materials to one another. In the top reaction we have 32 grams of oxygen and 4 grams of hydrogen. So I need 8 times as much oxygen as hydrogen by mass. This is something that Dalton could have measured. In my lower reaction, I have 32 grams of oxygen reacting with 2 grams of hydrogen. The ratio, 16. And these ratios are similar to one another. They're divisible by a very small whole number ratio, in this case 2. This is known as the law of multiple proportions, and it holds for a number of reactions in which we combine multiple substances to make more complex molecules, just like we're doing here. What Dalton did was to combine the law of conservation of mass with the law of multiple proportions to demonstrate that there must be some fundamental indivisible particle. In other words, you can't add a half of a hydrogen atom to a molecule. Therefore, you can't have a proportion that isn't either 8 or 16 in this type of reaction. This is what Dalton used to support his theory. And because it was his theory, he got to name these fundamental particles. And he chose the name atom from Greek words meaning not divisible. This is the source of the term that we use today to describe this fundamental unit of matter. That's all for now, everyone. I'm Professor Davis from ChemSurvival.com and the YouTube channel ChemSurvival. I'll see you on my next video.